Alright, today let's talk about domain and range. Alright, so first let's just start with the basic idea that when we're talking about functions at this point in our math lives, we're talking about this infinite set of numbers. So just for the coordinate plane, the domain is saying how far left and right we can go, and the range is saying how far up and down we can go. And for a regular plane, it's just all real numbers, right? So the domain of the plane has to do with x, and it is infinite left and right. So it's all real numbers. And the range of the plane has to do with y. So it's infinite up and down. So it is also all real numbers. Okay. So just from starting out, we're starting out with this. And then really the only time we have to worry about changing from all real numbers is if there's some sort of boundary or stopping point or limit. Some things that can create problems for domain and range. Let's see. Problems. Dividing by negative. Dividing by 0. Right, so if we have 3 divided by 0, there's no answer. Or if we have 3 divided by x minus 2, then when x equals 2, that's a problem. Okay, so those are times when we're going to have issues with our domain. X can't be 2, so here the domain would be all real numbers except 2, because 2 is going to create this 0 situation. If this here is just an x, then we could see that x is all real numbers except 0. Okay. Another area where we run into trouble is taking the square root of a negative. Now, we know we can. We get imaginary numbers, but we're looking at just dealing with, real numbers on the plane. So this is an even, actually not just a square root, but an even root of a negative. So for instance, the fourth root of negative 16. Unfortunately, my best light is right by my bunny cage, so I'm having a little bit of an allergic reaction to the hay right now. Sorry about that. So there's no answer to this, so we can't do this. So if we think about the fourth root of x has to be, for our domain, x is all real numbers greater than or equal to, greater than or equal to 0. Or we could just do that, right, for now. Okay, and then the third issue that we have with domain, just problems that we have to watch for, are if we're taking the log of a negative. Okay, so if I have log base 2 of x, this is saying 2 to what power is x? Well, if x is, let's say we have log base 2 of negative 4, 2, there's no power of 2 that can create negative 4, so that's not possible. So that's where we run into a problem here. So this is going to be the same as up here. X is greater than or equal to 0. It has to be a positive number. And then just like up here, let's say we have log base 2 of x, I don't know, plus 7. Then x has to be greater than or equal to negative 7, because if it's negative 8, we end up with a negative number, but if it's negative 7, that's just 0, so we can... No, that's not right. This is just greater than, it can't be 0. Sorry. So, right, because 2 to no power is 0. We can't make 0. Okay. Okay. So, that's just kind of the general 3 issues that we have to watch out for. Let me get this back over here so you can see it. And then, let's see, okay, so then let's talk about all the different types of functions we've had. And so we have talked about linear functions this year. Okay, well, linear functions are going to go forever left and right and forever up and down. So the domain will be x is all real numbers, and the range will be y is all real numbers. Okay, and then the exception to that is if we have a horizontal line, then our range will only be y equals whatever the number is. And if we have a vertical line, well, this isn't a function anyway, but so I'm not going to worry about that. But technically the domain would just be the one number and the range would be anything, but that's not a function. All right, so after linear, we did quadratic. Okay, so thinking about a parabola. All right, so parabolas, no matter what, are gonna keep going wider and wider forever. So the domain is going to stay x is all real numbers. And then the range is always going to be related to the vertex. So the range is going to be either y is greater than or equal to y of the vertex, or if it's this kind of a parabola, if a is negative, then y is less than or equal to the y of the vertex. And remember, we also call this the min, and we call this the max. Okay, and so that is directly related to that idea of range. So you can see forever it's going left and right. It's going forever in one direction, up or down, and then there's this a stopping point. There's a point where it won't pass. And then we talked about exponential functions. Okay, so exponential functions introduce this idea of an asymptote. So they're going to have this boundary that they're going to get closer and closer and closer to, but never quite touch or cross. So again, for our domain, we're going forever left and right. And our range is y is greater than or equal, no, not equal to, it's just such habit, y is greater than the asymptote, so I'll spell that wrong, okay, and you know, sometimes you have ones that are flipped upside down, so it'll be less than, but generally speaking, we see it up here in the top. And then logarithmic. My gosh, I can't spell today. Logarithm. Okay. So these are the inverse. So here we have the asymptote as an x value, so it's going to restrict our movement left or right. So x is greater than the asymptote, and our range is y is all real numbers. Oh my gosh, you guys, I am off my game today. That's okay. Okay, so just generally speaking, we're looking at left to right for the domain. Is there any limit to how far it can go? And the range is going up and down. Is there any limit to how far it can go? Are there any problems that we have to avoid? Let's see. I think that's good for now.